Are you guys ready? Related rates and min-max questions. All right, so good afternoon, ladies and gentlemen. Welcome to another live stream. Today, as I mentioned already, we'll be doing the typical word problems in Calculus 1. So hopefully if you're taking Calc 1 or maybe AP Calc A, B, and BC in high school, hopefully this video can be really helpful, all right? So altogether, we'll be working out 4 related rates and then 4 min-max questions. Of course, the file is in the description, right? I'm not going to write down the questions because that will take too much time. So I'm just going to read the question out loud and I'll also put down the important things on the board. So hopefully you guys can still follow along. If you guys need to read the question, just go to the description box, right? So I have all the questions there already. So the first 4 questions are related rates. Here we go. How are you guys doing? Let me know in the chat, right? So for the first question, it says a particle is moving along a hyperbola x squared minus y squared is equal to 5. So I'm going to write that down right now. We have a particle that's moving along this curve. And usually when you're given the equation, this right here shouldn't be too bad, right? And then it says as it reaches the point 3, negative 2, the y-coordinate is decreasing at a rate of 0.9 centimeters per second. How fast is the x-coordinate of the point changing at this instant? So this is how I like to do the related rate questions, especially how I like to teach students how to think through related rates. The key is draw 2 points, draw two pictures. First, this is given, so you know we will be looking at the hyperbola, and because we have x squared minus y squared, so this is the open left and right hyperbola. So it looks like this, and then we're just going to focus on the right-hand side, right? And of course, you have the other one. I just want to put that down just in case. Yeah. People say, hey, where's the left one? But anyway, you have a particle, and this is a typical question. So it's going to be moving along the hyperbola. So maybe it's right here, right? It's going to be moving around. You don't know where it's going to move. But it says, and this is where the second picture is coming. It says the particle is going to be moving at the point. It will reach the point 3, negative 2. So this right here is 3, and this right here is negative 2. All right? And now, let's go ahead and think about it. You see, the particle is moving, right? And it's going to be moving from here to here. And how do we know? Because it says the y-coordinate is decreasing. So the point's moving down. That's why the second picture looks like this. So hopefully, the 2 pictures will show you the movement. And yeah, right? So just to make you guys happy for that. Now, here is what I like to do. Here are 2 important words that you can possibly use to help you tremendously for related rates, actually for all the word problems. The first word is know. You're going to put down what you know, right? You're going to put down what you know. First, we know this equation, of course, so we are just going to put that down. We know x squared minus y squared is equal to 5. This is the equation that we are going to focus on. And it also says the y-coordinate is decreasing. So when you see that, you know that's going to be dy dx because that is a rate. It's decreasing at a rate of 0.9 centimeters per second. So we also know that dy dt equals negative 0.9. And when you write this down, don't bother to put on the units. Usually the units are the same, so you don't have to do any unit conversions. Unless some evil questions, they will say centimeters per second, and then the other rate is like, 2 feet per second or so. That's bad. But just make sure the units are okay, then you don't need to put on any units. It's cleaner that way. So we know this, and we know this. I think that's pretty much all we know, and this is what we want to know. It says, and this is the second word, it says we would like to know how fast is the x-coordinate changing. So you see, let me just do it again, like this. So you can see that the point is going down, right? Going downward, and it's actually moving to the right, right? And because we want to find out how fast, right, the rate of the x-coordinate, how fast is it changing, that's what we want to know. dx dt is equal to what? And here's another thing you have to know. At the instance that we are at that point, which is 3, negative 2. And of course, this is the x value and this is the y value. So this is pretty much it. That will be my summary for this question. And now we have the equation already. So this is like an angel question, you know, because we can just go ahead, look at this equation, keep in mind that x and y are changing. So we are going to differentiate this with respect to t. And because of that, the first one will get 2x dx dt, because x is changing. And for the second one, we're just going to differentiate that. So do the usual power rule, you get 2y dy dt. Differentiating 5 is the happiest thing in the world because you get 0. And now you can just plug in the values that we know. This is 2, x is 3, dx dt is, we don't know, that's what we want to know. So dx dt minus 2, and then the y is that, which is negative 0.9. I hope I have enough space to do all this related expression, all the min-max question, but we'll see. Anyway, dy dt is negative 0.9. And the reason it's negative is because the point is traveling downward. So you have to also pay attention to the direction. So, sorry, the y should be negative 2. I put that down wrong. The y value, I should put down negative 2. And then the dy dt should be this, which is negative 0.9. And then that's equal to 0. All right. So now I'm going to move this to the other side and divide both sides by 2 and 3. So you will see that dx dt is equal to, this will become positive, 2 times negative 2 times negative 0.9, and then divided by this and that, which is 2 and 3. And do it whichever way that you would like. I will tell you this right here is equal to, let me just write this down. It's going to be positive and we'll get 0.6. And finally, when you want to box the answer or whatsoever, notice that this is positive because in fact, we are moving toward the right. So that's why it's the positive direction. And then we have the positive rate. And this right here is centimeters per second. So usually just attach the unit at the final end. This is how I like to tell the students how to do it. All right, so take a look and let me know what you guys think so far. Hey, Sergio, are you guys okay? Can you guys see this okay? I don't know why Sergio put that icon. That is it loading? Is it not going? Is this going well? Looks good? All right, the connection is all right? All right, cool. All right, so for the people who just came in, welcome. And to see the words, right, the word questions, just go to the description. I typed them, oh, well, I didn't type them out. I copy and paste from the worksheet to the description box for you guys. So that's number 1. And this actually is pretty good because we have the equation right away. I don't know how long this will take. Most likely it's going to be longer than usual because I want to show you guys how to solve word problems for Calculus 1. And if you don't skip related rate, and if you don't skip min-max questions on your test, you know, that will tremendously help you with your grades. Seriously. Because from my experience is that a lot of students, once they see the word problems, they just don't even bother with it. That's horrible. They are not so bad. Trust me on that. Seriously. All right. Second question. I'm going to read that for you guys. Let me just put down number 2. And I'm going to draw pictures along the way. Hopefully that will be helpful. So number 2, it says, we have water is going to a conical tank at the rate of 9 feet cubed per minute. The tank stands pointing down and has the height of 15 feet and the base radius is 5 feet. So this is the typical cone question and then the water going into the cone. So here is your tank. So it's the typical cone, all right? And then we also know the measurement, so let's go ahead and put that down. Right here, the height is 15 feet. Again, just ignore the unit for now. I know for the physics teachers, I'm sorry, because I said that before in my video and then some physics teacher, they didn't like me to say that, but like, the point is, it's cleaner and just make sure that this is 15 feet and the radius right here is 5 feet. They have the same unit, so just ignore the unit for a little bit, right? All right, and then you have water that's coming in. Of course, water should be in blue. So just imagine that you have the water coming in and then it's going to be filled in, right? So maybe this is going to be the water level right here. I don't know, right? And of course, actually, let me just put down the first picture. Maybe the water level is only right here, right? So water coming in, and you know after a while, the water level is going to be increased. So here's the second picture. Second picture is going to be like, of course, we have the same tank. And again, this is still 5 and this is still 15. But the water level is going to be higher, right? Because you have the water coming in. Sometimes you may see the question that's like water is like draining out. So in that case, the water level will decrease. So when you're taking notes, when you are thinking through the questions, draw 2 pictures. That will be really helpful. This is what I tell my students. All right, next, what we do is, let's put down what we know and let's identify what we want to know. Well, let's go ahead and write that down right here. What do we know? We are talking about water tank, and this is a cone, upside down steel cone. You have to remember the formula for the volume of the cone. We know that, you have to remember this, the volume is equal to 1/3 pi r squared h. All right, so this is the formula based on the shape that we are doing. What else do we know? Let's see. It says the water is coming in at the rate of 9 feet per. The water is coming in at the rate of 9 feet cubed per minute. So in that case, what do we know? You want to answer that for me in the chat? The water is coming in at a rate of 9 feet cubed per minute. So how are you going to write that down in the calculus language? You also need to write down the calculus language, right? 9 feet cubed per minute. It's not enough. You also have to do the labeling. Randy, you got it. Very nice. Let's go and write down. We know that dv dt is equal to 9. So in this case, the v is actually for the volume of the water. And of course, the water goes into the tank. It becomes the shape of the tank. And that's like the Bruce Lee's quote, right? Be water, my friends. Once you put water in the cone, this is the cone shape, then the water becomes a cone shape. So anyway, dv dt is equal to 9. So that's what we know. And let's see, what do we want to know? Let me just put that down right here to make sure that I have enough space for everything. We would like to know how fast is the water rising, right? How fast is the water rising? So in this case, you can see that, well, if you look at the water, of course, this right here, this radius and this height, they will change. Once you have more water, you see the radius is getting bigger. Likewise, the height is also getting bigger as well. If they are changing, go ahead and write down variables. So this is the r and this is the h. So again, this right here is technically for the volume of the water, but again, it's in the cone, so that's why it's the volume of the cone. Well, we want to know what's dh dt. How fast is the water rising? At what instance? At the instance when the water is 6 feet deep. So we need to know this when h is equal to 6. So this is going to be the summary, right? Okay, maybe we can do what we did earlier. Just look at this and differentiate that. And you have to keep in mind r is a function of time. Likewise, h is also a function of time because they change. Okay, you can do that, but the problem is that, you see, this right here will require product rule because both the r and h, they are functions of time. So you can do it like that, use the product rule, and just make sure you do the implicit differentiation well enough. But you don't have to do it like this, because if you look at this, we can actually get rid of one variable by using similar triangle. And that's the typical way to do this kind of questions. Even though it's totally okay to get dr dt and also dh dt and find out the relationship, but that one might be slightly overkill. So let's do the typical way. Similar triangle, so you see that this is 15. This, of course, in the middle right here, it will also be 15, right? So let's do r over h. And this will be equal to 5 over 15, which is, of course, 1/3. And now, notice, we just care about the h dt, so we don't want r. That means we should solve for r right here. We can just multiply the h on both sides. This means, let me just say, this means r is equal to 1/3 times h. So this right here is the relation between r and h. Check this out. We are going to write this formula as 1/3 times pi times the r, which is 1/3 h, and then square that, and then h. All right, much better, because now we just have one variable. Pi is not a variable, it's just a constant, by the way. Anyway, this is 1 over 9 times that is 1 over 27, and then we have the pi, and then this is h squared times h, which is h cubed. So this is the volume formula in terms of just h for this cone. All right? Now we can do our favorite thing. Namely, we are going to look at this and differentiate this with respect to time. And as you can see right here, we get dv dt. Very nice. And then bring the power to the front and then -1, so this becomes 1 over 9. Pi is just a constant, you keep it, and then this becomes h squared. And remember, h is a function of time because it changes over time. So here you multiply by dh dt, and that's exactly what we are trying to look for. Now, plugging numbers, 9 here. You know the deal, I'm going to put that down in red. 9 here. This is 1 over 9, pi is pi, h is 6. You have to also pay attention to at what instance, because at different instance, the rate will be different. So h is 6, and you square that, and then you have the dh dt. All right, ladies and gentlemen, dh dt is equal to, I'm going to multiply 9 on both sides, so it becomes 81. And I'm going to divide pi, and then divide 36. So I'm going to write it as 6 squared, yeah. All right, so all that. And if you use a calculator, you will get approximately 0.716, right? If you use the calculator. And on the AP test, there are questions that you have to use the calculator, right? And depends on your Calc 1 class. If you are taking a typical Calc 1 class in college, maybe you just reduce the fraction on your own. You can do it, right? Reduce the fraction on your own and leave the answer with pi. Depends on the instructor. Anyway, here, the final unit is feet per minute because this is the distance, right? H is the distance. So the unit is feet. And then because this is the rate, so the unit for this number is feet per minute. And you see this is positive because the H is getting bigger and bigger. So have a look. How many of you guys are taking Calc 1? Let me know. Or maybe how many of you guys took Calc 1 and then this right here. Man, it brings back either the good or bad memories, right? Wait, how's the connection? I cannot really... Okay, the connection should be okay. Because I'm also looking at the screen right now on my laptop. I don't see myself moving. All right. We good? Okay, so hopefully once you start drawing two pictures, this right here will make more sense. Number 3, you know we are going to do a question that involves the Pythagorean theorem. This is the one. Okay, we have car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. They are heading to the same intersection. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? Of course, I'll show you guys two pictures. First one, of course, we have the intersection. So let's just put it down like so. Two cars, A and B. So I'm just going to say that this right here is car A. Yes, this is the car without. I will give you guys here the wheels. And then let me just make sure that like the car makes sense, and then 0.3 and so car B will be slightly lower. Actually, let me just do it like this. A little bit closer, because I want to show you guys. This is not like a, isosceles triangle, so I'm going to do like this. So this is car B, and yeah. Anyway, car A is going here, and then car B is going there, and then you cannot really see the wheel if you are looking like. Anyway, all right. So this is the first picture. Second picture. Well, both of them will be toward the intersection, so car will be a little bit closer. Let's say it's right here. They still have the wheels. And then car B is going to be somewhat like this, right? So this is car B. B right here, right? And then we have the horrible pictures. But anyway, all right, let's put down what we know. Right? What we know. First, you can see that we have a what? Two cars, and then this right here is 90 degrees. And the question is asking how fast is the cars approaching each other. In that case, that's a straight line distance, right? So the equation that we're going to use is actually just this. You see, from here to here, we'll call that to be A. Actually, let's use blue. You see, from here to here, we'll call that distance to be A, because here we have car A already. And then from here to here is car B. And we also need to care about the distance between them, straight line distance. And you can see that all three lengths changes, right? All three lengths changes, and they are getting smaller and smaller. So this is A, this is B, right? So let me just put that down right here. Maybe this is A, this is B. Let's put that down as C. Doesn't really matter. You can use Z if you would like, but why? Lengths. No angles are being involved, so we are just going to use A squared plus B squared is equal to C squared. And keep in mind that A, B, and C, they are all changing, so they are all functions of time. All right. Now, let's go ahead and put down what we know. It says car A is traveling 50 miles per hour, so we know that the A dt is equal to 50. It says 50 miles per hour, but here's the deal. You can see that the distance right here is getting shorter and shorter, right? So technically, this right here would be a negative 50, right? You just really have to look at the pictures, and if the quantity is getting bigger and bigger, then the rate is positive. But if the quantity is getting smaller and smaller, in this case, the distance is getting smaller and smaller, then in that case, the rate is negative. Similarly, the B dt, this is 60 miles per hour, so it will be negative 60. And this is important because sometimes you will see the question that car A is going toward the intersection, but car B is going away from the intersection. In that case, the sign really, really matters. If you have a wrong sign, then the number will, of course, totally be different. So we know this is the equation that we're going to use, and we know these are the rates that we have. And what do we want to know? The distance between car A and car B. So that's just going to be dc dt. We need to know what this is at the instance that A is 0.3 miles away from the intersection and B is 0.4 away from the intersection. So that's the summary for all this right here. And now, of course, we have the equation already thanks to the Pythagorean theorem. So we can just go ahead and differentiate this with respect to time. Here we go. A is a function of time, so the derivative of that is 2a dA dt. Similarly, next we get 2b dB dt, and lastly here is 2c dc dt. All right? And we can just plug in numbers and then see what happens. 2 is 2. I'm not going to cancel the 2. I think this way might be slightly easier. I don't know. A is 0.3. So let's put down 0.3. dA dt is negative 50. Plus 2 is 2. And then B is 0.4. Oh my god, I really don't have enough space. Let me try again. I'm sorry. Let me just try this again. dA dt is equal to negative 50, and then dB dt is equal to negative 60. All right, 2 is 2, and then A is negative, sorry, A is 0.3, and then dA dt is negative 50, and then 2 is 2, and then B is 0.4. And then dB dt is negative 60. That's about the same as earlier, huh? But I'm going to make this fit. C is what? Well, now we have to solve for C. A is 0.3, B is 0.4. C, of course, we can use the Pythagorean theorem right here. So we get, let me just show you the work. 0.3 square plus, oops, wrong color for that. 0.4 square, this right here will give you C squared, right? So you can solve this, you will get C is equal to 0.5, right? So C is actually 0.5. And lastly, we have the dC dt. There, right? You see, 2 times 0.5 is what? It's just equal to 1. So in fact, dC dt, because this is just 1, right? So it's just going to be all that. So I'm just going to write down 2 times 0.3 times negative 50 plus 2 times 0.4 times negative 60. Do all the work on your own, and then you will end up with negative 78, right? Negative 78. And now, why is this answer negative? Well, because as you can see, C is getting shorter and shorter as well, right? So that's why it's negative. And the question is asking, at what rate are the cars approaching each other? So the word approaching tells you the distance are getting smaller and smaller. So that has a negative already, right? So I will just write this down in a sentence. I will just say the cars are, oh, that's not, the cars are approaching, so just want to make it super clear, approaching each other at 78, right? Because I'm using the word approaching already, so I don't have to use the negative sign right here. Approaching each other at 78, and the distance, I mean the unit right here is miles per hour. So this right here will be my response for that, right? So I'm going to give you guys a better marker. Let me see if I have that. Okay. So take a look and let me know if you guys have any questions. Put this right here. Okay. Take a look. All right, so hopefully this is clear, and let's move on to number 4. Notice if you look at the file, number 4 is actually not a multiple choice. Usually for my Calc 1 class, I give a quiz just on related rates and also on optimization questions. So I can force the students to really have to know how to do these questions. And usually I will give 3 multiple choice questions and 1 that's not multiple choice for related rate, and I'll do the same for the min-max questions. So I'm pretty much using my quiz format for the live stream, and 8 questions is a good number. Here is the question. It says, we have a television camera is positioned 4,000 feet from the base of a rocket. And today I think the Starship is launching, right? How many of you guys are watching? Anyway, we have a rocket launching pad. And then it says the angle of elevation of the camera has to change so that you can keep track of the rocket, right? And it says the rocket is rising vertically and its speed is 600 feet per second. And we would like to know how fast is the camera's angle changing when the rocket is 3,000 feet. All right, here is the picture. All right, this is the rocket. It's on the floor right now, right? And then we have a little camera thing, little device right here. So of course, you're going to keep track of the rocket. Let's say it's the top, oh, just the picture, don't worry about that. And of course, this is the first picture. And you do know that the distance from here to here is 4,000, right? Second picture. The rocket is somewhere in the air now. So somewhere like this. It looks like a house, but you know what I'm going to give you? The fire. Anyway, and then this right here is the distance, of course. And then this thing is still right here. And the distance from here to here, it's still 4,000 feet because the rocket is going straight up. If the rocket is going with an angle, then maybe you will have to use law of sine, law of cosine, things like that. But anyway though, that's pretty much the deal. And let me just put that down right here. So as you can see, the things are changing is pretty much everything besides that. And we do have to care about the angle, right? So just keep that in mind. We do have to care about the angle, so keep that in mind. So let's do some labeling. Let's say this right here is x. Let's say this right here is x. And let's say this right here is y. Because the typical horizontal distance and also the vertical distance. But we do know x is equal to 4,000 and it's a constant, all right? And because the question is talking about the angle, right, the angle of elevation, so we have to come up with an equation that involves x, y, and the angle theta. So let's go ahead and put down what we know, and then also, of course, let's put down what we want to know. Well, this is the opposite, this is the adjacent, and this is the angle. So use the trig function. That will be what? Which trig function can we use? In the chat, go. X, y, and theta. So which trig function can we use? Tangent. Cook star, right? Well, Custer actually with the 3 for the E, right? Tangent, excellent. So I'm going to write this down as, we know that we can use tangent theta being equal to y over x, right? And go back to the question. It says the rocket is going up and has a speed 600 feet per second. So we know that based on our labeling, we know dy dt is equal to 600. Good. And we also know x is equal to 4,000, and this right here is just constant. So let me just, write that down right here. X is 4,000, it's always 4,000. All right, let's put down what do we want to know. We want to know how fast the angle is changing because you can see that originally the angle is like this. Technically, if I want to make the picture the same, if I line up here, I should do like this. Yeah, right? So we're keeping track of the top of the rocket. I don't know, but like it's the same place. Anyway, we want to, it's a lot of fun to teach related rate and also min-max because we can talk about stories along the way. It's actually more fun to talk about than integrations or just differentiation, in my opinion. Right? All right, we want to get the d theta dt because remember, angle changes over time as well. So this is what we want to know. At what instance though? At the moment that the rocket is 3,000 feet. So we want to know this when y is equal to 3,000, like that. All right, come back here. Well, I have a good news for you guys. Because x is always 4,000, right? It never changes. So you can put in 4,000 right here for the equation. So we can look at this as tangent theta equals y over 4,000. And then we can go ahead, just go ahead and differentiate this with respect to time. And please, when you write this down, always put the ddt all the way in the front. Never put it in the back because this is the correct notation, right? Anyway, tangent theta, remember your derivative, you get secant squared theta, but because theta changes over time as well, so you multiply by d theta dt. Now take this derivative right here. Well, this is, you don't need to use the quotient rule for this. This is the same as 1 over 4,000 times y. So you have the 1 over 4,000. The derivative of y is just dy dt. All right? Good. Now, plugging the numbers, well, I will do the left-hand side. We'll do the right-hand side first because it's easier. Because we know dy dt is equal to 600 feet per second. D theta dt, we don't know. Now, we have to figure out secant squared theta. You have two ways to do it. You can figure out what theta is, and then do the typical secant of whatever angle is and then square the result. You don't have to do it like that though. Keep in mind, y is equal to 3,000. We haven't used this yet, right? When y is equal to 3,000, let's look at what we have. If you look at this triangle, when y is equal to 3,000, that's going to be right here, and x is 4,000. Well, if we have this side, which is the hypotenuse, then we'll be able to figure out secant of that angle. So let's go ahead and figure this out. Of course, you know 3, 4, 5, but with 1,000, right? So that should be pretty clear. And with this picture right here, we can figure out the secant theta, which is hypotenuse over adjacent. And technically it's just 5 over 4. So we are going to just write down 5 over 4. But don't forget we are going to square this. So for this, again, it's just because by looking at this triangle, secant theta is equal to 5,000 over 4,000, which is 5 over 4. And the square tells you how to square that number. So that's how we got that. All right, I'm going to just multiply by the reciprocal to the right-hand side, and then you guys do the fractions on your own. We get d theta dt here. That's equal to, I'm going to put this over there. I'm not going to reduce anything. Pretty bad, but anyway. And I will do the reciprocal, which is going to be 4 over 5, and then square that. Do the fractions on your own, or maybe use your calculator on your own. And this right here we get 12 over 125, which is equal. This is actually a very nice decimal number, which is equal to 0.096. You guys can help me a little bit. What's the unit for this? What's the unit for the final answer? This is the rate for the angle. So what's the random gainer? Yes. Yeah, so this right here is going to be radians per second. The random gainer. Thank you. So that's it. And of course, depends. Some teacher may have you write down the fraction. So yeah. So take a look. So these are the 4 related rates questions that I have for you guys, and then the last 4 questions will be min-max. So if you guys would like to see more related rates, you guys can leave your comments in the comment box below, and I will see what I can do for you guys. Maybe I can come up with like a quiz, have you guys work on it first, and then I will do another live stream, maybe on my other channel, because I'm doing this one right here already. So let me know. And seriously, if you're willing to do and learn related rates and also min-max, this will really improve your grade. Maybe to go from a D to a C, maybe to go from a C to a B, etc. Right? Okay, so are we ready for the min-max questions? And by the way, right now is 2:13. What did you guys have for lunch? Or maybe breakfast, or maybe dinner, I don't know. But what did you guys eat earlier? This is actually one of the new traditions that I'm starting with my students. I like to ask them, oh, what did you guys eat for lunch? What did they eat for breakfast? Things like that. And usually I get a lot of fun answers. So you guys can let me know. I'll take a look at the chart right now. What did you guys eat for lunch or that? Oh my god, I have some super chats. Thank you so much, Christian, and also JSS. Thank you so much. Oh, so some of you guys eat fish, water, burger, and then you starve, and rice, chips. Okay, you ate some maps there, and nothing. Oh, shout out to you in Egypt. Wow, that's really cool. Peruvian fish. Wow. I never had Peruvian food, so I wonder how that tastes. Banana and hot dogs. Don't know if you have the, and then salad. Okay. Chicken stew. Okay. Chicken pie. All right. I had a bagel earlier, and it's a smoked salmon bagel from Noah's Bagel. If you guys like that place, if you guys know that place, you can leave that in the chat and let me know. And I have some Starbucks coffee, so that's my usual routine. Bagels are good. All right, let's go ahead and do the min-max questions. Here we go. It says, if 300 centimeter squares of material is available to make a box with a square base and an open top, find the biggest possible volume of the box. So here is the deal. We have a box. This is a typical construction question. So we have a box, and the box is going to look like this. It's not going to be a cube. I don't know it, okay? But the only thing that we know right now is that the base is square, right? So that's pretty much how the box looks like. And just to make it clear, we don't have top. So this is an open top box, right? Open top. No top. It's just like box, like a container. All right. So we want to find the biggest. We want to find the biggest possible volume, given that we have the set amount of material. So for the set amount of material, it means that we have the certain amount of cardboard or paper. So when you fold up, it magically becomes a box. So I'm going to break this down for you guys. First, the base right here is a square. So I'm going to write that down. I'm going to draw that down right here for you guys. All right? And then if you look at this side, this side, and that side, well, you have this. You have this. You have this. You have this. So this is when you open the box. Just imagine you cut, and then you just, slide it out, then you will get this, right? So this right here is where the set material is coming in. of course, we have to come with some labeling, some variables, so we can come up with an equation. And let's see, because the base is square, so let's say this is x, and this will also be x. But I don't know how big that is, so I'm just going to call that to be another variable, let's say y. Right? Well, right here, it's the same thing. This is x, that's x. And this part right here will be y, and this will be y, and then, yeah, all that stuff. All right, two important words. Hopefully, this is the best thing that you guys can get out of this live stream today. Two important words. Tell me in the chat, what are the two important words that you should know to organize the information? Two important words. So Kong Huan, what you know and what you want to know, right? So these are the two important words. The first thing, we are going to write down what we know. Because we know that we have 300 square centimeter of material, so we're going to look at this, and we're going to look at the area. So first, you see, we have this square, so I'm just going to color this right here. So that's going to be x times x, so we will have x squared. And then, right, and then you can see that this right here is x, this right here is y, so that's just a rectangle, and that's going to be xy. Similarly, this right here is x, that's y, so you have xy, and the area here is also xy and also xy. Altogether, we have 4xy, so we are going to have plus 4xy, and all in all, this right here is 300 square centimeters, right? And then, let's see, what do we want to know? Well, right here it says we want to have the biggest possible box. So I'm going to write it down like this. We want the maximum, right? We want the biggest, and we want the volume. Well, if we're talking about volume, let's look at this. The volume of a box is just going to be all the things multiplying together, right? So the length times width times the height, so x times x, which is x squared, and then you multiply by y. So this is going to be the thing that we're trying to get the maximum out of. We cannot do calculus with x and y. This is not calculus 3, right? So when you have the equation with x and y right here, what we do is we go back to what we know, and this right here is called the constraint equation. Let's solve for y. So to do that, you can see that y is going to be 300 right here. I'm going to minus the x squared. And then we have the 4x right here. So let's just divide everybody by 4x. Like that. Right? So we can just go ahead and just reduce this a little bit if you would like. This right here. Let me just write it down like this. So we know the volume is equal to x squared, and the y is that, which is 300 minus x squared over 4x. And we can simplify this a little bit. You can see that we can cancel out one of this, and that's just going to be x. So we get x times that, which is, let's do it this way. 300 over 4 is 75 times x, yeah? And then this is minus 1 over 4, so we have minus 1 over 4. And this is x squared times x to the first, so we have x to the third power. Yeah, just like that, right? So this right here is the volume formula, right? So here, let's go ahead and put that down right here. And because we have an equation with just x, so I'm going to write it as v of x. V of x is just equal to 75x minus 1 over 4x cubed. Now, what should we do so we can get the min-max? You guys tell me. What should we do so we can get the min-max? Yes, we are going to take the derivative. So right here, again, because this is calc 1, that's why we didn't want to differentiate this right here. Look at this. We are going to differentiate that. So the notation is just going to be phi prime, phi for the volume of the box. The derivative of this is 75, And the derivative of this is going to be minus 3 over 4x squared. And in order for us to find out where the maximum is going to be, we are going to set this to be 0, so we can find out the critical numbers, right? All right, I'm going to move this to the other side, but we'll write that down first. So we get 3 over 4x squared. This has to be equal to 75. And then I'm just going to multiply both sides by 4 over 3, multiply both sides by 4 over 3, typical things. X squared equals, reduce this, you get 100. So you can see that x is equal to plus or minus 10, yeah? After you take the square root both sides and things like that. Might as well show you guys the work. Remember the good old days that you do all this and that's it for the question? All right, now, of course you can rule out negative 10 because negative 10 in our context, it wouldn't make sense. We are talking about geometry. But let's also verify that when x is equal to 10, we actually get a maximum. To do so, I would like to use the second derivative test. So look at this and differentiate this again. We get v double prime is equal to 0, and then this is going to give us negative, and then bring the 2 to the front, we get 3 over 2, and then we just have x. And when x is 10, put that in, you get negative 3 over 2 times 10. Well, this is positive, this is negative. When you multiply, you get this being less than 0. You see, the first derivative is 0, means that it's flat. And the second derivative is less than 0, means it's concave down. So, right here, we can be sure that we can say we will have a maximum at x equals 10. And this step is kind of like depends on your instructor to see if he or she wants to show work for this or not. And ideally speaking, you should. But if it's a multiple choice question, you most likely know that 10 is the answer for the x value. Now, if you are taking the AP calculus test, be super careful. You always have to answer what the question is asking, right? Especially for multiple choice. The question here is that we are going to find the biggest possible value. So 10 is not the answer. We are going to go back here. I will just write this down right here for you guys. I'll put this down, run no space, but I'll put this down right here. I'll say answer. Maximum volume is when x is equal to 10. So that's going to be phi of 10. And how can we do that? You can just put a 10 in here if you would like, or here, and then just find out what y is, and by just put it here. So anyway, 75 times 10, and then minus 1 over 4 times 10 to the third power, and then do the math on your own. Altogether, you will get 500. Right? And then the unit for this, because its volume is centimeter cube. So this right here is the answer. All right? So take a look. Right, x is 10 and y is actually 5. So altogether you get 500. So yeah. How many of you guys see the poll I put up earlier? Like yesterday, not earlier. I actually knew that we'll be doing related rates and min-max already, because the condition is that I will pick the one that has the least number of votes. And I explained why already in the post, right? So just, yeah, because usually your least favorite topic is the one that hurts you the grade the most. But anyway, hopefully you guys can see these are really not so bad. As long as you know how to construct, how to organize what the question is asking, and how to construct the information, and how to construct the equations. And the rest is just the typical calculus steps, right? Right, so that's what we have. All right. And just to mention this real quick, you can also do the first derivative test, but usually second derivative test for this kind of question is quicker, in my opinion. Right. Would you guys like to have more practice questions? If you guys do, let me know. Maybe after we finish the live stream, just leave the comments in the video, and then I will try to collect some more questions because I have lots of questions from the handouts or maybe from the exams, the quizzes that I had in the past. I can share with you guys if you guys would like. Okay, number 6. This is the hard one, all right? Number 6, it says we are going to find the equation of the line that goes through the point 5, 2, and that cuts off the smallest area from the first quadrant. Here's the deal. You have a point 5, 2. Let's say it's right here. This is given 5, 2. And then we are going to have a line that cuts through this point, and then we are going to have the smallest area in the first quadrant. Let me just make the picture slightly smaller. Let me say 5, 2 is actually about right here. So you can have a line that goes like this, or maybe like that. I don't know, but I'm just going to maybe put it down like this. We must have a line that goes down like this. So of course, the equation of the line is y equals mx plus b, right? You can also look at the answer choices. So we want the equation in the slope-intercept form. This is not an easy one, but if you organize the information, it's not so bad. Anyway, we want the line so that this area here is going to be the smallest. It really depends on how you have the line. Yeah. However, there's a special function that no matter how you do it, the area is always the same. I don't know if you guys know what I'm talking about. It's an interesting question. Maybe we'll do that another time. So again, let's put down what we know and what do we want to know. So perhaps this time I'm going to put it down right here because one picture is enough. We know the equation of the line is y equals mx plus b. That we know. We also know that we have this point. So because we have this point, 5, 2, remember this is x and this is y. So we can plug in x and y into here. That means we must have 2 is equal to m times 5 plus b. And this right here will give us a relationship between m and b. Because remember, as long as we know the m and b values, then we can get the equation of the line. Okay, pretty good. Now, let's see what do we want to know. Well, we want to have the smallest area here, so that's the minimum. And because we want area, let's put down area here. But how would you write down a formula for the area of this triangle? Remember, the area of the triangle is always base times height. When we have the height and base right here already, you can just do that. So now, here's the deal. Let's figure out what's the base right here. Let's put this down in blue so that it stands out better. This right here is the base. Notice, it's just from 0 to wherever this point is, but this point is precisely the x-intercept of this line. Better yet, you should just put the 0 into the y and solve it. So 0 equals mx plus b, and just solve for x. Move the b to the other side, so you get negative b, and then divide it by m, so you get negative b over m. So this right here is negative b over m. Yeah, you don't get actual number for the base. Similarly, let's figure out the height right here. Guess what? That's just the y-intercept, and which is really straightforward. It's just b. And just to show you guys work, you will just get y equals m times 0 plus b. and y is equal to b. Right, so that's how we get the b. Yeah. So coming back here to find the area, again, it's 1/2 times the base, which is negative b over m. And then times the height, which is the b, like that. And of course, you can clean this up a little bit, but the deal is that, again, this equation has m and b, has two unknowns. We don't like that. So let's look at this again. If we know 2 is equal to m times 5 plus b, we know that this will give us b being the same as 2 minus 5m, right? So right here, I'm just going to write this as negative, we have the b times b, which is b squared, over 2m. And now you can see that b is equal to that. We can just put that down. So I'm going to write this down right here for you guys. And a. I'm going to put this down right here. So a will be a function in terms of m, and that will be negative. B is that, which is 2 minus 5m, and you square that, square, and then over 2m. Wow. This doesn't look like that friendly, huh? But that's how it is. So I'm pause for a little bit and let's see how you guys are doing. So, Richard, yes, in this case, we know the gradient or the slope is going to be negative, right? We can know for sure. But we'll see how we will get later on. So take a look on this. And by the way, I don't know, you guys know this or not. Why is that when we have y is equal to mx plus b, why is the m for the slope? Why don't we use s? Why do we use m for slope? Do you guys know why? Why do we use m for slope? Well, the real reason is that nobody knows. But if you want to know a fun reason for it, I will tell you, M for mountain, and mountain has slope. That's why. I know it's not funny, but whatever. Anyway, now, hopefully we are okay in terms of how we get this equation at the moment. The rest is just that we are going to do the typical thing. Namely, let's go ahead and clean this up a little bit, and then we'll do the derivative. So let's do this right here. A of m. I'm going to multiply that on the top, which is going to be this right here square, which is 4, and then minus 2 times this and that, which is going to be 20m, and then plus this thing square, which is 25m squared, and then all divided by 2m. So here's the deal. Let's split the fraction because the bottom is just 2m, so we can do that. Usually it's a very good idea to do algebra first before you do calculus. Good luck to you if you want to use the quotient rule and also the chain rule and then whatever rule you want to use to differentiate this. I will choose algebra over calculus all day. So here's the deal. Negative 4 divided by that. So 4 divided by this is 2 and also the m. So I'm going to write it as 2 and I will write it as m to the negative 1 power. But that will be negative right here. Next, negative is plus. 20 divided by 2 is 10. And then m cancel. Next, negative positive is negative. 25 over 2, oh my god, I have to keep it as how it is. M squared over m is just m. Right, so that will be the reduction for all the things. Now, calculus time. A prime, namely the derivative of a. Do the derivative, bring the negative 1 to the front, and then minus 1. We get positive 2 now, and then m to the negative 2. Derivative 10 is 0. Derivative this guy is just that guy, which is negative 25 over 2. Now, go ahead and set this to be 0. I'm going to move this to the other side and rewrite this as 2 over m squared. Let me write it down like this. I know I'm going to run out of space, so let me put this to the other side. So here I will have 2 over m squared equals 25 over 2. Yeah? And I'm going to multiply m squared on both sides to show you guys the typical algebra. And then I'm going to multiply the reciprocal of this on both sides. So 2 over 25. Maybe this is not the best way to do it, but like I am doing it already, so just kind of bear along. There. Anyway, this gives us m squared equal 2 times 2 over 25. So for all this, you will see that m is equal to plus or minus 2 over 5 after you take the square roots on both sides. A lot of times people don't like and people just don't want to deal with negative answers. But in this case, if you look at the picture, you should know that m should be negative. So what we want to do is we are going to get the second derivative and then we'll plug in m being equal to negative 2 over 5. And I'll show you it will be a minimum. So second derivative, I'll put that down in blue. So a double prime of m equals the derivative of this guy, just negative 4 and then m to the negative 3. The derivative of this is 0. That's good. And then you will see that a double prime at negative 2 over 5 is going to be negative 4 times negative 2 over 5 to the third power, negative third power. Check this out. Negative, this inside is negative, raised to a negative third power, this is going to be negative, times another negative 4. Altogether, we get positive. So this right here is positive. So by the second derivative test, when the first derivative is 0 and the second derivative is greater than 0, so you have a situation that looks like this. So it's a minimum. So we can say we do have a minimum at m equals negative 2 over 5. And that's exactly what we are looking for, the minimum. And now, because m is equal to negative 2 over 5, what's the b value though? Let's put that down right here. b will be 2 minus 5 times the m, which is negative 2 over 5. Work that out, you will get 4. Oh my god, I feel everything to the I'm so happy. Ladies and gentlemen, I'm going to write down the answer for you guys. The answer right here is going to be y equals m is negative 2 over 5. M is equal to negative 2 over 5. Let me just write it down better. X. And then the b is 4. So this right here is the answer for it. Oh, everything fits on this whiteboard. I'm so happy. Alright, so have a look. I'm a big fan of fitting everything onto one whiteboard. That just makes me really happy. Alright, how are we doing? Let me know. And what if we put 2 over 5, right? If we put a positive, well, let's analyze. If we put a positive 2 over 5, you will have a slope that looks like this. And it becomes really weird. Actually, I didn't work that out. If you put a positive 2 over 5, this would be positive, that would be negative, then it looks like it's going to be a maximum. But you're going to get like a really weird answer because when m is 2 over 5, it's going to be maybe like this, right? 2 over 5 is going to be like this. And yeah, you will get a maximum area, but it's actually infinite, so it's not, doesn't quite make sense. Yeah. Again, if m is 2 over 5, you actually get the line that looks like this. And you pretty much have infinite area because it keeps on going forever. Yeah. Supreme Sector, I'm happy to hear that you passed your differential equation test. Good job. And where are you taking the class? Let me know. All right, seriously, I do have a lot more fun to talk about optimizations and related rates because each question has a story behind it, and then you have to analyze the question, not just like do the question, right? All right, 2 more to go. Gaming real time, thank you so much. And you have a ring and fields test in an hour. Wow, that's like abstract algebra. Best of luck to you. Okay, let's look at number 7. Number 7 says we have a swimming pool and we are going to build it so that the swimming pool has the area of 2,450 square feet. The owner wants to have a 5-foot wide docks along each side and then 10 foot at the 2 ends. What are the dimensions for the whole thing so that you can get the smallest piece, right? So it's always clear to make a picture, so let me just show you. Let's say this right here is the swimming pool. Let's say this right here is the swimming pool. Yes, water and all the good stuff, of course. You know that the area right here, it has to be 2,450, right? So that's the swimming pool. And you know what? Let me make this blue because I want to just show you guys the swimming pool. This right here should be in blue. Sorry about that. All right. Here we have the swimming pool, and then we know that the area here is 2,450. But usually when you have the swimming pool, it's not enough. You must have docks around the swimming pool, right? And you pretty much will have a bigger rectangle around the swimming pool. But the distance from here to here, it's going to be 5 and 5, 10 and 10. So the picture is going to look like this. Non-drawn to scale, of course. But again, as I mentioned earlier, this right here should be an additional 5 and then an additional 5. And then for the top and bottom, this right here should be an additional 10 and then an additional 10, right? Now, you know what we are going to do? Yes, labeling the things that we don't know. Do we know how long this should be? We don't know, so let's go ahead and put that down as x. Do we know how long that should be? We don't know. Let's put that down as y. Well, let's look at the outside. Do we know how long this should be? Yes, we do. This right here is x already. 5 more, 5 more, so altogether, from here to here, should be a total of x plus 10. Similarly, from here to here is y already. 10 more, 10 more, so altogether this right here should be y plus 20. So that's the picture. Okay, so what do we know? And in this case, it's just a constraint equation, and that's going to be x times y, it's going to be 2450. So put that down in blue because it's water. So x times y is equal to 2450. Now, let's see, what do we want to know? We want to have a smallest piece, so we want the minimum. And in this case, we're talking about area. So let's put on A. Well, the area of the whole thing, so it's going to be just this times that. So I'm going to put it as x plus 10 times y plus 20. We have to minimize this thing. But again, we have x and y, no good. Don't worry though, you know the deal. X times y is equal to that, so perhaps that's solve for y, meaning that we will get y equals 2450 divided by x, and then we can put that down in here. So ladies and gentlemen, the area equation is going to be a of x, and that's equal to x plus 10 times the y is the 2450 over x, and then plus 20. So that's the equation that we have to work with, right? So I'll pause for a little bit. I'll see what you guys are doing. It looks like the print paper one. Yeah, sometimes this can be like the poster question as well, like the print paper, and then like you have to have the picture frame or like the additional empty space around it. So same thing. Yeah. So there are a lot of typical calculus 1 related rate or min-max questions. If you're willing to study them all, then you can know them all. Of course, they are like the hard ones as well. You may not have to know them, but these are the typical ones. Study at the harder end. I didn't go over the easy ones today. Are we good? All right. So remember, do algebra first before calculus. You will be so much happier. Let's do it. A of x. X times this, we just get 2450. This times that, we get plus 20x. This times that, man, I'm just going to put down 24500 over x. This times that is plus 200. All right? And you know what I'm going to do? I'm actually going to rewrite this as this times that as 24500, but x to the negative 1. Yeah. I don't want to add the numbers because when I differentiate, it becomes 0 anyway. So this is gone. Let's say bye-bye. This right here, the derivative that is 20. The derivative of this, bring the power to the front, minus 1. We get negative, okay? Negative 24,500 here, and then x to the negative 2. For this, you guys know it. Let's say bye-bye to it. It's gone. All this is the derivative. Go ahead and set it equal to 0. Do the typical thing. It really depends on how you like to do your algebra, seriously. I'm going to move this to the other side. So we have I'm going to write that down first though. We have 24500 over x squared equals 20, right? Just move that so you see it's actually both positive. And then just multiply x squared on both sides, I'll say. So this and that cancel. And then divide the 20 on both sides. So divide the 20 on both sides. Cancel this guy out. And you will see x squared equals 1, 2, 2, 5. Yeah, 1, 2, 2, 5. And then if you take the square roots on both sides, don't forget the plus minus. The minus doesn't make sense, I know. But anyway, though, x equals plus or minus. You know the answer for this? It's actually 35, right? All right, so that's what we have. And again, you should know that negative answer in this case doesn't make sense because we are talking about geometry. But again, I will show you guys the second derivative test. So a double prime of x, this will be 0, and then differentiate that, we get positive, and then we get 4. Oh, let's see. Are we back? Can you guys hear me? Oh my god, didn't know that the thing went off. And why does he say it includes a paid promotion? This is not being paid actually. But anyway, I will go over this real quick with you guys. So you again do the typical second derivative test, and you'll see that when you have x equal to 35, y is equal to 70, and that will indeed give you a minimum. And finally, you have to answer what the question is asking, which is the dimension of the whole property. So you have to put 35 into this x here, and you get 45. And then when you put 70 into the y here, you will get 90 feet. So remember, you always have to answer what the question is asking. So the dimension of the whole property is 45 by 90. Right, so let me know if you guys are seeing the video okay, because on my laptop it's kind of blurry, I don't know why. So I'm going to go and then change it to can you guys see this okay or no? Let me know if you guys can see this okay. Yeah, is it clear? HD for you, why is it not HD for me? Okay, I got it. Don't like that whenever like the internet goes off. But anyway though, hopefully this is clear and then just take a look again. I do have a class in like 30 minutes, so I have to finish number 8 real quick. Number 8, it's not like hard, but it's just the computation is not a nice number. All right, so have a look. Good? Okay. So I know a lot of you guys maybe have in your past Calc 1. Calc 1 is like, I don't know how many years ago is for you guys. Hopefully you guys remember all this question. And by the way, how many of you guys are tutors at your school, or maybe do private tutorings, or maybe do we have any teachers in the chat as well? I'm going to erase the board. I will look at the chart real quick after I finish erasing the board. Do we have any tutors or maybe even teachers? Ah, I see you are a tutor from Hong Kong. I see, nice. Hello? And then Robert, you are a physics tutor. Nice. And then Richard, you are a tutor. You tutor math online. And then oh, we have a teacher. Nice. Oh, Sergio, you tutor at Fullerton College before COVID. Do you still do like tutoring? Sometimes like tutors, they can work via Zoom. I don't know if that's the case for your school. Okay, let's finish the last question. Again, this is the last question. I do have a class in 30 minutes. Question: you have a 10 meters long, right, wire, 10 meters long wire. You are going to cut this into 2 pieces. The first piece is going to be made into a square. The second piece is going to be made into a regular triangle. And we're going to see how to cut the pieces so that we can form the smallest area. So here's the picture, very easy. That's the picture. Anyway though, altogether is 10. And altogether is 10. And then we're actually going to make a cut. Right? We're going to make a cut. And because I want to follow my format, like what you know and what we want to know, so I will just purposely say, I don't know how long this is, I will call that to be x. I don't know how long that is, I will call that to be y. But I think you guys know this right here is just 10 minus x. Doesn't really matter though. Anyway, we are going to make one piece and we're going to make that into a triangle. And then the other piece, we're going to make that into a square. And we are going to see what's the smallest area that we can get. And this is actually very interesting. Because if you use the whole thing to make a square, or if you use the whole thing to make a triangle, you'll get different answers for the area. And there's actually a fine point. That if you use the right amount for the triangle, if you use the right amount for the square, you actually get the smallest area, right? So anyway, though, that's what we're trying to deal with. It's actually easier if you say this is x and then for the triangle. It's symbolically easier, so I'll do that. So I'm going to use this portion for triangle and this portion for the square. And just to make it super clear, this right here is the x. I'm going to make that into a triangle, and this is a triangle. Because the whole thing is x, I know this is not drawn to scale, right? So don't judge my picture. I know this is the same as that already. This is x. This, and that over 3 because it's equilateral, right? Okay. Similarly, this right here is y, and of course that will just be y divided by 4 because this is a square. Perfect. Now, this is what we know. X plus y is equal to 10. I know. So I'm just going to put down x plus y is equal to 10. The reason I want to do that is so I can follow the same format. I didn't want to say this is x, the other one is 10 minus x. That's, yeah, I skip one step, Anyway, we want the minimum of the area of the equilateral triangle and also the square. What's the area for the equilateral triangle? I will remind you guys on the side. When you have an equilateral triangle, if the sides are s, right? If the sides are s, you can prove this real quick. You just draw down a perpendicular, and then this right here will be s over 2. And then this right here will be square root of 3 s. Let's see, over 2. Yeah, because it's the 3690 special right triangle. But anyway though, if you know the formula, most likely your teacher will let you use it right away. You get square root of 3 over 4 because half of this and that, right? And then times 2, so yeah, square root of 3 over 4 and then s to the second power. So that's for the whole thing. Okay, so we're going to use that. So we have square root of 3 over 4. I'll put that down in, well, let's put this down in black. Square root of 3 over 4. And then the s is equal to x over 3. So we have the x over 3. And then we are going to square that. Plus, well, the square area, you need no introduction. We're just going to have y over 4 and then square, right? So that's what we are trying to get a minimum out of. So you can see that you do need to know some formulas like the volume of the cone, the area of an equilateral triangle, maybe the law of sine, law of cosine sometimes, depending on if your teacher lets you know ahead of the time that what formulas that you are expected to know. All right, this is not great because we have the y right here, but don't worry, you know this right here we can minus the x on both sides. Y equals 10 minus x. It's following the same format, that's why. Anyway, a of x in action, we get, let me just write down the whole thing, square root of 3 over 4, and then we have x over 3 square plus the y is 10 minus x over 4, and then we square that, okay? Work this out. This is actually just quadratic, so the derivative is not bad at all, but that number is pretty bad. Anyway, square root of 3 over 4, and this is, let's do this, yeah, let's do this. Save some space. This is square root of 3 over 4. But 3 squared is 9. 9 times 4 is 36. And then we have the x squared, right? Okay, plus, multiply on the top, we get 10 squared, which is 100, minus 2 times this and that, which is 20x, and then plus that thing squared, and then all divided by 4 squared, which is 16. And perhaps, let's just divide everybody by 16 right here. Save some space, So divide this guy by 16, divide this guy by 16, and divide this guy by 16. And enough, I'm going to do the derivatives. A prime. Differentiate this, we get square root of 3. 2 in the front, so 2 over 36 is 18, and then x. This is bye-bye. And then we have just minus 20 over 16. Reduce that by 4, we get 5 over 4. Yeah? And then, of course, the derivative x is just 1. Lastly, put a 2 in the front, so 2 over that, which is going to be plus 1 over 8 x. Like this. Yep. Yeah. set this guy equal to 0. Notice they have the x term, so I'm going to factor out the x, and then we will have square root of 3 over 18 plus 1 over 8. And then x. And then move this to the other side, so this is equal to 5 over 4. Now, get a common denominator, do the usual business. Multiply this by 4 and 4 because the common denominator is 72. So multiply this by 9 and 9, right? So this is why I said this question is the number is not ideal. X equals 5 over 4, and then we have 72 on the bottom right here, right? Multiply by the reciprocal, so the 72 will be on the top right here, over the bottom here is 4 square root of 3 plus 9. And then, if you would like, we can reduce this to be cute a little bit. So you can see that x is equal to, this times that is 90 over 4 square root of 3 plus 9. Okay? And I just want to show you guys what we did earlier. This is quadratic, so you know right away because it's open upward. So, right, the parabola is open upward, so this is minimum already. Yeah, but anyway though, I'll show you guys this real quick. A double prime of x is just equal to square root of 3 over 18 plus 1 over 18, and then a double prime of that number, 90 over 4 square root of 3. I know you guys will be like, do we really have to show this? Well, depends on your teacher, I would say. And anyway, square root of 3 plus 1 over, no, not 18. 1 over 8. Square root of 3 over 18 plus 1 over 8 is clearly positive. So we do have a minimum at this x value. Yeah, let me just write it down. Okay, x equals 90 over 4 square root of 3 plus 9. Okay, done. It should be enough explanation already, right? So just the typical thing. Okay, we're going to finish this strong. We're going to see how to answer this question. It says we are going to explain how the wire should be cut so that the total area from the square and also the equilateral triangle will be the smallest. Well, so we will just say something like this right here. Remember, is for the triangle. So I will just say 90 over 4 square root of 3 plus 9. 4 square root of 3 plus 9, which is approximately 5.65. And this is for meters, right? Meters. For the equilateral triangle, I think that should be enough. And then 10 minus that number, I'm not going to reduce that or simplify that, whatever. I'm just going to write that down. And this right here is approximately 4.35 meters for the square. All right, this right here is it. The hardest part for this right here is just to work out the exact answer. That's all. All right, so take a look and let me know if you guys have any questions for this real quick, and that'll be it for today. So if you have any questions or anything, I'm going to answer it real quick. Oh, good to hear, Andrew. You like this question with the square and also... Oh, you like it with square and circle, right? It's similar. I think I made the triangle because I just wanted to increase the difficulty a little bit. But square and circle, square triangle is the same idea for this. So hello? Argument, hello? Albert, hello? And let's see. Andrew, you say you expect your students to be able to define both minimum. Oh, yeah, the tricky part is that if you want to, this is the minimum, right? And for the maximum, you have to just check the endpoints. Either you make the whole thing for the triangle or the whole thing for the square, and you are going to just test out the endpoints. Very nice. Thank you so much for that. Yes, I am a teacher. Yeah, I'm a teacher. In fact, I have a class in 20 minutes. Oh, good to hear, Sergio. Good to hear that you like the questions. It's a good reflection. Yeah, and if you work as a math tutor, expect students to ask you questions like these: related rates and min-max questions. Okay? I teach at a community college in Los Angeles. Am I a mathematician? You can say I am, or you can say I'm just a math teacher. Yeah. To be honest, I'm not that into mathematics in terms of like doing the research or whatsoever. I am more into like teaching. Yeah. How am I so good at math? Well, I don't really consider myself as being that good at math. I study a lot, I practice a lot. I think that's the secret for it, right? Okay, so I think that's enough for today. It's a pretty long live stream. Hopefully you guys get something out of this. And if you have students who are taking Calc 1, if you know your friends who are taking Calc 1 or AP Calc, maybe this video will be helpful. And later on, I will also try to cut this into smaller pieces and go to my other channel, because I think that will be beneficial for the students as well. If you guys want to have more examples, just leave a comment down below after this video is being uploaded. Then I will see what I can do for you guys. All right? I will see you guys next week. Bye.